Welcome to the CertificatePulse demonstration. This is a controlled local simulation. Every entity, certificate identifier, QR code, key pair, and integrity record shown in this presentation is synthetic. No production certificate authority, personal identity data, or live credential is used. We begin with the client setup. The QuantumLock software development kit is installed, and the local components are checked. This workflow uses ML-DSA-65 for the digital signature. It uses SHA-256 hashes to track local integrity evidence. ML-DSA is the signature algorithm specified by NIST in FIPS 204. It supports a transition toward cryptographic protections considered resistant to known quantum computing threats. The CertificatePulse workspace now prepares a new synthetic certificate. The entity is labeled as a synthetic test entity. The certificate type is marked as a demonstration credential. The selected policy is quantum-signed ML-DSA-65. When the certificate is issued, the local environment creates a signed payload. It records a public key digest and a payload hash. It also creates a local QR validator reference. The QR code is only a visual reference for this test workflow. It is not a public credential. Next, CertificatePulse validates the original certificate. The signed payload is checked against the locally generated public key. The result is valid, quantum signature verified. This confirms that the original certificate content still matches the signature created during issuance. Now we simulate a certificate alteration. The entity value is changed after the certificate has been signed. This creates a different SHA-256 digest. The original signature no longer verifies against the altered payload. CertificatePulse returns invalid signature. PQC verification failed. This is the expected control result. A modified certificate must not be accepted as if it were the original signed record. The workflow then seals a local evidence bundle. The bundle records the issued certificate, the original validation result, the altered payload result, and local integrity data. The evidence is signed locally with ML-DSA-65. The Trust Console provides the governance view. It confirms that one synthetic certificate was issued. It confirms that the original validation passed. It also confirms that the altered payload was rejected and that the evidence bundle was sealed. A production deployment requires validation in the organization's licensed environment. It includes key management, policy controls, audit retention, and operational integration. SoftQuantus offers a 4-week proof of concept. First, choose a priority certificate workflow and define the success criteria. Next, validate signing, verification, lifecycle controls, evidence capture, and integration requirements with approved test data. Finally, review the technical and governance evidence to define the appropriate production path. Start a 4-week POC at softquantus.com.